Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. We are from Group 3, want to present Lab 3 Refrigeration System.
Today I'm gonna present about the procedure of the refrigerator lab. First, we must switch on the machine. Next, switch on the power switch. Third, switch on the condenser fan. Fourth, switch on the heater power. Then, wet the meter cut off turn into 27 degrees Celsius. After that, switch on the water pump. Then wait for 5 minutes before we take data. Next, for the seven step, we take data from screen to fill the data table in the lab sheet. So from the screen, we take temperature 1 to temperature 6 from screen. Then for high pressure and low pressure, we take the unit bar. After that, we take 1 kilowatt from the other screen. Next is we take flow meter data, then convert from milliliter to liter per minute. After we finish to take the data, we must switch off the condenser switch. Next, switch off the heater power. Next, switch off the water pump. Switch off the power switch. And last, switch off the machine power. Work process for lab 3 refrigerator. Okay, first, after we do the procedure, we switch on, we turn on the main power, the switch power, the condenser fan, heater power, and wait until 27 degrees Celsius. And we switch on the water pump. This is water pump. Okay. What's going on when the machine is operated is first. When the machine is on, the compressor will start doing. The compressor will compress then the condenser will blow out the heat. We can sense hotter the wind that blow from condenser. After that, through the valve, then it's going up. Then it's going up. Then the water in this will evaporate. Go down. Okay, I'm sorry. In this pipe, the water will get in. And the cooling agent will in also. Okay, the valve will make the cooling agent go. Then combine with water. Then we go down. In this coil, they are combined. Then you will go down. Right up there. Go down. Then water is come back to the cylinder. And cooling agent will be evaporate. Then it will go back to the compressor. That's how the cycle of the refrigerator from compressor, it will go to the condenser. Then at the compressor, we know that the temperature is high and pressure is high. Then at the condenser, the pressure is high, and starting from extension valve, the temperature will go down. Then at the water out, the temperature also go down, the evaporation also go down, and lastly, when they come back to the compressor, the pressure will high. Okay.
Okay, now we move to safety regulations. There are a few safety regulations that should be aware in this lab. First and foremost, make sure the work surrounding is kept clean to ensure the lab process are smooth. After that, when taking the lab reading, make sure everything is stabilized to avoid parallax error when taking reading measurement. Time taken to stabilize may depend on surrounding conditions. Moreover, make sure the valves are in normal condition. This ensures that the vapor is drawn by the compressor and the condensed liquid goes to the evaporator. Last but not least, report any incidents or damages happen in the lab to the technician in charge or the departmental safety representative. So here is the graph of pH diagram. So for the process 1 to 2, it was a compressor. So the refrigerant enters the compressor as saturated vapor. A compressor driven by an electric motor compresses the steam and increases its pressure and temperature. From process 2 to process 3, which is the condenser, this high temperature superheated steam enters the condenser, where it condenses at a higher temperature than the heat sink. Therefore, heat moves naturally from the condenser to the environment. From process 3 to process 4, which is the expansion. This high pressure fluid enters an expansion valve or capillary tube that lowers the pressure dramatically to the original pressure. This throttling happens. The temperature of the refrigerant drops sharply to a temperature lower than the temperature of the refrigeration chamber. So from process 4 to 1, which is the evaporator, here the refrigerant is cooler than the refrigerant chamber. Thus, heat travels naturally from the cooling chamber to the evaporator, whereby heat absorption happens. This causes the refrigerant to evaporate. So from this pH diagram, we need to get the value for the enthalpy to fill in the table 2, which is the enthalpy table. So from the pH diagram, we get the value of H1, which is 398 kilojoule per kilogram. And for H2, we get the 428 kilojoule per kilogram. And for the value of H3 and H4, each will get 240 kilojoule per kilogram. So to calculate the COP refrigeration, you have to use the formula H1 minus H4 divided by H2 minus H1. And we get the answer, which is 5.2667.
The cooling cycle of a heat pump is used to cool a space by removing heat from it and expelling it to another area, usually to the outdoor for air conditioning or to the room for a refrigerator. To do this, the evaporator and condenser coil switch role and the flow of refrigerant is reversed. The cool refrigerant absorbs heat from the hotter room in the evaporator, so the room will cool down. It is then put through the compressor to increase its temperature. It passes through the condenser coil and transfers this heat to the outside air. It then expands in order to decrease its pressure and cool down below the room temperature to repeat the cycle. The calculation for overall efficiency is by using formula E equal to watt over Q height. As we can see, Q low we already calculate in part F. To get value of Q height, we can get from formula Q low equal to Q height minus watt. Value of Q low and watt we already have, so we can easily get value Q height. After we get value of Q height, we can calculate the overall efficiency which by using the formula. For part F, for heat transfer calculation, we use the given formula. All the data had been given, follow the data given, and we will get the result for heat transfer. Lastly, for part G, the calculation for overall efficiency of the refrigeration machine is by using formula QL over power in. The QL is the heat transfer that we calculate in part F, and power in is the value of compressor power consumption in table above. All the data ready and just direct divide to get the overall efficiency result.
Discussion. Based on the result of our experiment, it can be concluded that as the heat load in the cool store grows, the temperature risks increasing the quantity of refrigeration boiling off. If the compressor cannot move, the pressure on the suction side of the compressor risks, as does the evaporation temperature, slowing the evaporation rate and causing the condition to correct. The impact is to raise the temperature in the cool space, preventing the need for more compressor capacity. The volume of the vapor per kilogram of refrigerant change as the evaporation pressure and temperature change. When the pressure falls, the value risks the refrigerating effect, which is mostly determined by the rate of refrigerant circulation, must also be reduced. The compressor capacity is reduced if it is forced to run at the lower suction pressure and vice versa. As a result of the significant increase in refrigerant circulation per unit time under high suction pressure and high circulation rates, and the motor becomes overwhelmed. The amount of the refrigerant circulated is basically unaffected by change in condenser pressure. The maximum value of this COP refrigeration obtained is given by the value of 5.2667. It shows the pattern. The coefficient of performance was straight, then coefficient of performance refrigeration will get positive quantity. The coefficient of performance, the efficiency of a refrigeration, is given by parameter. Then we get the overall efficiency of the refrigeration machine is 0.86%. Conclusion. In conclusion, the refrigerator has two compartments, one for frozen goods and the other for refrigerating but not freezing stuff. It can dissipate and cool off of the heat generated by the load. This experiment was complete in its entirety at the same time, with all of the required parameters being computed and solved when needed. A vapor compression refrigeration system is an improved type of air refrigeration system in which a suitable working substance, termed as refrigerant, is used to produce cooling effect.